Hello, everyone. Welcome to the Data Science program in Computer Science Department at USC. My name is Yan Liu, a faculty member in Computer Science Department. My research area is machine learning and data mining, which are the foundations for data analytics. First, I would like to welcome you to this exciting program on a really beautiful campus. In this short video, we are going to give you an introduction of data analytics and what are the exciting opportunities in front of us. I hope that you'll find the video useful. If you have any further questions, don't worry. Please visit the program website for details or contact with the student advisors directly. They will try out their best to help you. Here, I wish you best luck in your studies and the best of your career.
We all know that big data or data science is a very, very hot buzzword that you can hear in industry, in academia, or even talked by the president. Actually, when we talk about the data, they actually have existed for many, many thousands of years. So these are type of the ancient forms of data that we have seen or the archaeologists have collected. For example, we can have knotted animal hair, which they will record the number of days that they have experienced, or the cuneiform or cupel. And these are all the nice forms of data representations even before the computer was invented. Obviously, we all know ever since our data have been stored into the computer as a particular structure currently known as the structured data, then actually the accumulation of the data has becoming much more and faster and in a streaming fashion. So this is just a history of the data that we created. For every day now, we have created 2.5 quintillion bytes of data. So you can imagine that how much of data that we have created so far. When we talk about the data in computer, we usually talk about the specific form, which we always know as the matrix form. So here in the slide that we show on the right-hand side, we have these matrices. Each particular row will represent an example or instance, and then each particular column will represent a particular feature. Once we have these matrices, we can do a lot of things. If you happen to know a little bit about machine learning or data mining, then you will know, oh, actually I can make predictions about the category of the features or the continuous values that we're interested in predicting. So these are the very general form of representation of the data by the computers. Obviously, in practical applications, we're going to see much more complicated form. One example of the complex form of data that we have experienced so far is what we call as the unstructured data. This can be referring to the text or the images or the video, where right now all these big companies such as Google, Facebook, or YouTube, they have started storing a large number of these different type of unstructured data. Here are just some statistics. For example, for Google, they have to search over 850 terabytes of text data, or for Facebook, they have collected 240 billions of number of images. So as you can imagine, this large amount of unstructured data will provide interesting challenges of how we can actually do analysis, do search, and do a lot of interesting work on top of the particular unstructured data. And similarly, another type of data is what we usually call as the network data, where essentially the data will be represented as a particular form, either as a graph or matrices, where the node will represent some particular interest of items, and edges will represent the dependence relationship. For example, Facebook have stored a social network of 1.1 billion of users. For the biological network, we have 500,000 of biological proteins with lots of interactions. The third type of complex data, which we usually know as time series of spatial time series data, this essentially will record the records of a particular items that we're interested over the time. And one specific example that we can have, especially in Los Angeles, we are going to experience is about the traffic. And for traffic at NTS, that is the National Traffic Department, where they're actually recording 500 megabytes of sensor data every day. And similarly for climate application, where we have collected 6 petabytes of spatial time series data, which we essentially are going to raise significant challenges for us to analyze and also to store and do operations in the first place. So these are the many different types of complex data that we are going to see in the practical applications. And these are essentially going to be the examples that we're going to experience while we're discussing different types of machine learning or data mining algorithms. So the central theme of the data science essentially involving 4 paths. First is the data management. Second is about data analytics. Third is about data visualization. And of course, the fourth but not the least important, essentially those are the most important thing, are actually the different type of applications. In the specific discussions later, we're only going to focus on the data analytics. I'm going to show you a few very classical examples of successful data analytic applications. The first example is actually about the IBM Watson system. So as we all know that for IBM, they have built a particular inference question answering machine which they can answer questions raised in the Jeopardy. And as we all know that they actually have been trying to collecting all the unstructured text data online, which they are going to process the data. First store the data, process the data, and also after that, what are more important is that they actually extract knowledge by analyzing this unstructured text data and then doing different type of inferences. In the end, they will be able to draw answers for different type of questions raised in Jeopardy, which is essentially a very classical example of how machine learning or data mining can be applied in the practical applications. Another example is about the human genealogy project. This is a classical example where essentially we use statistical models to analyze all the genes that we collected from human beings of the blood samples that collected over different populations, where essentially by analyzing these samples of genes from different populations, we will be able to generate the specific human migration map. So you can imagine the power of analytics in the sense that given this thousands of number of genes from human beings, then we will be able to build a statistical model based on their similarity of different genes. We can actually infer how human actually migrated from the Africa into Europe, Asia, and to other parts of all over the world. A third example I want to give is actually the education. You probably have heard about all this revolution of education system. Right now, online education is a very, very trendy topic. And in there, not only they provide a particular interesting and convenient venue for people to learn, to take classes, more importantly, they will be able to actually learn how students will learn these different type of materials so that we can provide the best education. Classical examples we have, you may heard of, is about the Coursera or some other online courses, where essentially they will record student activities so that we can provide the best individual or personalized education system. So hopefully by these 3 examples, that is IBM Watson system, the human genealogy project, and also the smart education system, we can provide you some sort of examples of how the data analytic, different tools of data analytics can play in the actual applications. In this particular program, you are going to learn a lot of the different type of skills in machine learning or data mining, where you can apply these different type of applications or your own application. So hopefully this is going to be a very exciting experience for you.